My name is Arnold, and today I'll be teaching you about empirical design. So first off, what is empirical design? It's pretty much a set of rules and guidelines that we can use to design certain types of masonry structures. In empirical design, there are no given set of equations or really technical calculations that you have to do. The design is based on ratios and rules that are derived from historic construction. Guidelines for these, this is where I got my tables and information from, are from the Masonry Design Guide and our TMS, and there's actually quite a bit of information on empirical design in both of them, where I didn't even have to look at the textbook, so there's more than enough in both of those. So historically, kind of the origin of this type of code is from the Code of Hammurabi. And Hammurabi, for the Code of Hammurabi originates from an ancient set of Babylonian laws about 4,000 years ago during ancient Mesopotamia. And so this was a set of civil codes that really applied to anything. An example of how this was used for construction is it's called Statute 229, which states that if a builder builds a house for someone and does not construct it properly, and that house which he built falls in and kills its owner, then that builder shall be put to death. So obviously we're not using it literally today. We're more taking that concept of having a code of, kind of like a code of ethics or a code of guidelines, and we're implementing that into like our empirical design, or overarching, we have the IBC, which we use today. The first modern design code was the American Standard Building Code of 1944, which was created by the National Bureau of Standards. Some limitations that we have with empirical design is that they're low tensile bond strength and that they're really limited to masonry elements with significant mass. This building here is actually a multi-story building that was created using empirical design.
That's my building, isn't it?
Yes. Yes. It's your building?
Yeah, that's the one that I posted on the historical one.
Yeah.
The Monadnock building.
Yeah, so it was designed using empirical design. And I think there's actually some settlement issues with it now.
As heavy as it is, there should be.
It's really big.
Go ahead, I'm sorry.
No. So some more limitations that we see with empirical design. One is it is derived from historic usage, so it's really kind of difficult to get modern adaptations because we base it off of what we can see from history. A big thing is that it has to be massive. You really can't use small structures with empirical design for it to be effective. And another thing is the openings that you have in your structure are small relative to the wall area. An issue with that today is that our buildings are now taller and slimmer, and there's more stringent design loading requirements that we use today. Also, most buildings we want the big picture window. We want wall or floor-to-floor glass, and that's not possible using empirical design. There are limitations that are related to building exposure, building height, design, and design wind loading, and then these are given in tables in the TMS and NVG. And then the TMS 402 section 8.2 specifically states that lateral force resisting systems can be no more than 35 feet high. So that is the height limitation for empirical design. So some general masonry design requirements. This is a list of really basic ones. And some of them you wouldn't kind of guess you would be using, but first one, project drawings must include a listing of the loads used in design. And then details of anchorage to structural members, frames, and other requirements must be included. You have to include provisions for dimensional changes, including volume change that could occur. And if walls are connected to structural frames, the walls must be designed to resist the interconnecting forces and to accommodate calculated deflections. And then there's a couple that are just basic. But number 7 is actually very important. The general masonry design requirements allow unrestricted use of empirical design in design category A, but with B and C there are more restrictions, and it can't do anything in design category D. It's not allowed. So here we have a checklist. I know this is kind of small, but this is in table CCA 1.1. And it's actually in both the Masonry Design Guide and the TMS. And so this kind of tells you what's allowed per each section. So here we have the seismic design categories, and then some of them are just basically outlining the checklist that I had previously.
Next time you have one like that, or what I
Break
found,
it up.
cut it in half and put that top table in there, which is just the seismic requirement, and maybe,
Yeah.
refer
I was
to
thinking it
the
would be a little bit bigger on the
Yeah.
side. But it wasn't.
It's not.
So, but you can always
Remember the 6x6 rule. Just remember the 6x6 rule.
Okay. So some materials that are not allowed in empirical design are glassine and masonry, and then the AAC masonry. So we just learned about AAC. Can't use it in empirical design. Some concrete masonry requirements are that the normalized flip area should not be less than 27 inches squared per foot squared, and that the member has to be solid or grounded solid. These are some requirements for lateral supports, and they are designed to limit the threshold tensile stress due to out-of-plane loads, and the requirements control maximum ratios for L over T and H over T, and then WS is the dimension of the structural wall strip measured perpendicular to the span of the wall strip, and WS shall be no less than 3 feet on each side of each opening. WT is the dimension parallel to WS from the center of the opening to the opposite end of WS. And to actually apply that to what it is, I have a picture. So this is kind of talking about openings and how we're going to control the wall system. So WT is the distance from the openings, and WS is perpendicular. And that's kind of the visual representation of what those are. Next, so a lot of the limitations or guidelines we have are in tables. So this is table 15.3.1, which is limiting your building height based on wind speed. And so your building height has to be 35 feet maximum. That's the maximum it can be. And so it gives permitted wind speeds for that height, and so it'll go to any height you want. You can find what your ratio is for your basic or your building height. Table 15.3.2 has the diaphragm length to width ratios. These tables are actually found in both the TMS and the NVG. So this is what, that's the wrong table. I have a duplicate table, so I'll fix that. So this should be your diaphragm length to width ratios.
Yeah, that's the same one.
It is the same one, so I copied it wrong. I'll fix it and update it so it'll be correct in there. But that just gives you the diaphragm length to width ratios, what you can have for your floor influence. Next, we have allowable compressive stresses for empirical design of masonry. So this is table 8.4.2, and I tried to fit it as best as I could on all of this, but it's a lot of information, and so it has grounded masonry, solid masonry, masonry of hollow load bearing.
So Bonnie's got you covered now.
Thank you, Bonnie.
All the compressive stresses that are used in empirical design as well. There's also table 15.3.3. We have lateral support requirements for empirically designed walls without openings, and so that gives us the maximum L over T or H over T. And bearing walls, non-bearing walls, cantilever walls, and parapets. Table 15.3.4 is the minimum empirical thickness requirements, and so we have thicknesses depending on what kind of wall you are using. So if you have a stone wall, it has to be at least 16 inches thick, which is pretty big. And I'll go back to this. So doing this, they're all pretty substantial thicknesses, and so that kind of ties back into that these are massive constructions. They weigh a lot, and that's imperative for empirical design. Table 15.3.5 kind of goes more to the foundation construction, and so foundation is taken into account for empirical design. And so this is the maximum unbalanced backfill heights for empirical design foundation walls. And so just depending on what kind of construction you're using, it gives you thicknesses and depths. And again, thicknesses are still pretty big, but pretty normal foundations. For the thickness of masonry, all minimum thickness requirements are based on nominal dimensions of masonry. So for minimum thicknesses, I'm not going to read all of them, but for the load-bearing walls, 6 inches for 1 story, 8 inches for more than 1 story. Again, we have the 16 inches for the rubble stone walls, which is pretty substantial. And here's kind of an example of checking your openings to make sure that you're within the minimum or you're not above the maximum requirement. So I'm just going to show one of these, but for wall line 1, which is this wall here, our minimum length is 0.2 times the long dimension. So our long dimension is 50.67 feet. And so 0.2 times 50.67 is 10.13 feet. And so if we look at this, we're going to add up our wall lengths that are the unobstructed through openings. So from here to here we have 24 feet 8 inches plus our 7 foot 4 inches. And that will give us 32 feet, which is greater than 10.13 feet. So we're okay there. And it goes through every wall line and checks to make sure that we're greater than 10.13 feet. And so it's pretty simple. It's not too, line crunching because it is using ratios and simple equations, not big, long calculations. So here's a diagram panel length as well, kind of an example diagram. And my sources again were the building code, or masonry designer's guide, and which is the building code requirements. Any questions? Yeah.
This actually may be a better question for O'Hara, but do you know when would be like a time you would want to use empirical design versus, is there any situation that you know it would be better to use that?
Well, if you're doing simple structures, you can do them very quickly. I think that's the key. Dr. Klinger down at, former Dr. Klinger, who's retired from the University of Texas, used to give a presentation called Masonry 101, and he could show you how to design a simple one-story box building using empirical design in an hour.
Yeah.
With everything, details and everything. And so for very simple things, you can do it without really having to worry about a calculation. There's even reinforcement requirements that are in there that will tell you, what you have to do around an opening, et cetera, as long as you meet these requirements. There's actually a whole publication now that came out. It's called the direct design method. Now, it's not like the direct design method in concrete. It's more like the empirical design taken to the next step, including some analysis portions of the code, where you can actually come up with reinforcing and sizes and lengths, etc., for a building using very simple calculations. The masonry people put it out, and it's a pretty good sized publication, but it'll cover a lot of the simple structures that go beyond empirical design, but maybe don't require you to do a really, really in-depth analysis. Okay, where the wind or seismic might be higher, wind might be higher than is allowed, but it allows you to design some pretty simple structures.
Yeah, I think what you can look at is the seismic